Alright, grade 9s. We are looking at chapter 6, which is all about number patterns. Now, as you can see there, we've got three main types of number patterns that we deal with. Firstly, we have linear or constant difference number patterns. Now, constant difference number patterns is going to be when we add or subtract the same number to get to the next term. We also have quadratic number patterns. Those are special types that follow on from your term number squared or even cubed and plus or minus something. We're going to talk about them a bit later. And then we have the constant ratio number patterns. They are often referred to as geometric series or sequence. And that is when you multiply or divide by a number to get to the next term. So the main ones I want you to focus on is going to be the linear and the constant ratio ones. So linear, add or subtract a number to get to the next term. And constant ratio would be multiply or divide. So in this lesson, we're only going to look at the constant difference, the linear number patterns. But we're also going to look at some terminology. So let's look at some terminology. Firstly, this is just how we write certain things. Let me get my little pointer. And this is a notation example. So this would just be how we would write that term number 2 has a value of 6. So the second term in the number pattern has a value of 6. Okay. It is just a notation. When we say Tn, when you see the little n there, that is known as the general term, and it can be any natural number. We are obviously excluding 0 because a number pattern cannot start from 0, and it also can't be negative, so it starts from 1 onwards, 1, 2, 3, and 4, and so forth. Okay, to get to a number pattern, and we're going to look at a couple of examples now. This is going to be your general solution. That is how you solve it. Now, there are more complex ways to do it that you will learn in grade 12 or even in grade 10, but it is going to be more complex than the solution that we're going to look at. This might not make a lot of sense right now, but you will see in a minute where we are heading. So, we need to identify two things. We need to identify our constant difference between our terms. So if we are given a bunch of terms, a number pattern, we need to see what value we are adding or subtracting every time to get to the next one. That is going to be multiplied by n. N is just a placeholder for the term number. And then we add or subtract whatever we need to from the constant difference to get us to term 1. Okay, that is all theoretical. Let's see how it works in practice. So, given the following number pattern, 3, 5, 7, 9, 11. And then also while we are at it, these are the questions you can be expected to ask or to be asked. You can see there we've got write down the next 2 terms. They can ask you to write down the next 1 term, 2 terms, 3 terms. They can ask you to determine the general term in the form Tn, or they can just say determine Tn. That will be the general solution. And the general solution will always be an equation that you can put in any value for n, which is a term number, and you will get back the value for that term. I'm going to talk a bit more about term numbers and term values. Then they can ask you what the value is of term 120. They can give you any number here. This is just the number I picked. And then they can also ask you the opposite question, to which they ask, which term has a value of 199? And the parts there in black is just other forms other ways they can word the same question, but these are the four main questions that you can be asked in number patterns. Okay, but first I want to have a look at this, at our number pattern. So I'm going to grab it, I'm going to move it way to the bottom, and I'm going to enlarge it. So we can just talk a bit about the notation as I mentioned earlier. So these are the terms that were given to us. We were given 3 as term number 1, we were given 5 as term number 2, 7 as term number 3, 9 as term number 4, and 11 as term number 5. Okay, so that is the value of n for each of these terms. So that means I can write this as term 1 is equal to 3, term 2 is equal to 5, term 3 is equal to 7, and so forth. And I need you to see the link between the term number and the value linked to that term, and that's going to be different for every number pattern. Now when we talk about our constant difference, that is something completely different. That's what we need now to establish our general form. Okay, but before we get there, let's actually just have a look. Our first question asked us to find the next two terms. Now you should be able to have a look at this, 3, 5, 9, 7, 11, and you should be able to see that between each term we are adding 2. Okay, just an addition of 2. So we can keep that pattern going, and we can do that to 11. So I'm going to jump right to the top again, and let's fill that in here. We were at 11, so if we add another 2, that's going to get us to 13. So I'm going to write it as term 6 has a value of 13, and term 7 has a value of 15. That's if we add another 2 to the 13. Now you do not have to write the term number, you can just write 13 and 15 as your next two terms. That is also perfectly acceptable. This is going to be just a more mathematically correct way. But here we get to the main bulk of what this section is about. And that is going to be finding the general term. This is going to be an equation that when you plug in any term number, so be it term 4, it is going to spit out the value for you, which in this case would be 9. Okay, so let's see how we do that. I'm going to grab this and take it with me, because that's what's going to help us here. Let me get rid of some of the extras here. And let's see. We want to first, like I said at the start, we want to first identify our constant difference between our terms. So whether we're adding or subtracting, what number are we adding or subtracting? And in this case, we've identified it already. We are adding 2 every time. So that means this is going to be replaced by 2. If it's negative, you will include the sign. If it's positive, you can leave it out. And let's move this up a bit. And we know that 2 times n is just going to be 2n. Okay. So that's the first hurdle out the way. Now we're going to look at 2. And we're going to see what do I need to do to this value of 2 to get to my first term. What do I need to add or subtract from or to 2 to get to 3? I need to add 1. So that means my general solution is going to be 2n plus 1. And I strongly urge you to go and test this. We've got 5 terms of this number pattern, and all you need to do to test this is plug in the term value. Pick one at random. We can take term 3 for example. And I can say that term 3 is going to be 2 times 3 plus 1. 2 times 3 is 6, plus 1 is 7, and we can see that matches up. It would be wise to test more than one, but in general, if you follow the steps correctly, you will have your general term sorted. And let's go drop that in the where we were working. So we know that our general term is 2n plus 1. Now you can do this at the start already to help you find the next terms, because you could have gone and said 6 times 2 is 12 plus 1 is 13 for the sixth term. And the seventh term you could have said 2 times 7 is 14 plus 1 is 15. So you could have started there and used this to find your next two terms. Okay, but in any case, then our next two questions are dependent on your answer here. So if you get this wrong in an exam, we will mark with your mistake if you've got the wrong solution here, or the wrong general formula, we will mark with your mistake and see what your answer would be. And we work with it. But let's assume that you all got it correct, and we can jump into the third question. The third question is going to be very similar to how I just tested my solution by using the third term. They just now want to know what is the value of the 120th term. Now we're not going to go and add 2 to 15 to get to the 8th term and then another 2 and another 2 until we get to the 120th term. That's why we have the general solution. So all we're going to say is that term 120 has to be equal to 2 times 120. Once we replace n at the bottom here, we replace it in our formula as well. And to that we still have to add 1. Right. 2 times 120 is 240, plus 1 is going to be 241. So that means term 120 has a value of 241. If you went and wrote out the number pattern to the 120th term, you would have found it to be 241. Okay, so we've covered the first general question you get asked, which is find the next 2 terms or 3 terms or even just 1 term. Finding the general term, as in overall, the formula that will get you to any term, and then finding a specific term value. Now, the last type of question is backwards. We are giving you a term value and we want to know which term number has that value. So it's going to be a case of, if I said that which term is equal to 241, your answer should be 120. The 120th term has a value of 241. So let's have a look. This one is set up a bit differently. We already have the term value. We've got it as 199. So we're going to say 199 is equal to our general solution, because we now want to know which value for n is going to give me an answer of 199. And then we're going to do basic algebra. We're going to solve this equation. So to get rid of the positive 1 on this side, we're going to move it across and we're going to subtract it, meaning that we end up with 198. And 2 is being multiplied by n, so when it goes across, we're going to divide by it. And let's see what we get. 198 divided by 2 is going to be 99. So in essence, that means, make a little bit of space here. In essence, that's going to mean that the 99th term in this number pattern will have a value of 199. So that means we started at 3, we kept adding 2's to each term to get to the next one, and when we got to the 99th one, the value was 199. There is one question I have not added here, which I'm actually going to add right now, which I can also ask you, and that is describe the number pattern in words. Let's call it the 5th one. Describe the pattern in words. Now, the biggest mistake you make in this question is not telling us where you start. You often tell us you add 2 or whatever the case may be. You sometimes even say 2n plus 1 and you write it out in words. That's not the right way to approach this question. We want you to tell us in words where we're starting and what we are doing to get to the next term. So if I had to put it in words, I would write it as follows. I'm going to say that starting at 3, add 2. So that's all we need. We started at 3 and we add 2 to get to the next term. And we continue that to finish off the number pattern. Okay. That was the first example, covering all of the basic questions you get asked for this. Let's look at the second one. You can see it's very similar, except they did not ask you in this case even to give the next number patterns or the next terms. They went straight for the general rule, the nth term, the 40th term, and which term number is equal to 603. So let's have a look. We've got 8, 13, 18, 23. And you should be able to have a look at that and identify that we are adding 5 every time. Okay, so to get to our general solution, again, same thing. We're going to take our constant difference and say that times by n. What do I do to 5? So my constant difference to get to my first term, which is 8. 5 to 8, I need to add 3. Again, suggestion would be to test this. I'm going to do it just orally. Let's say this is the 4th term because it is the 4th term given to us. 5 times 4 is 20, plus 3 is 23, so it all checks out, it works. So from there we can go on and we can say that the 40th term, which is our next question, is going to be 5 times 40 plus 3. Now, we don't expect you to do that. That should be 203, but let's make sure there's no need to risk it if you have your calculator. And yes, it is going to be 203. And again, lastly, if they ask you for which term is equal to a specific value, you have to set that value equal to your general solution. So I'm going to say 603 is equal to 5n plus 3. And then we have to solve the equation. So the n needs to get onto its own. 3 is going to go across and we're going to subtract it, which is going to leave us with 600. So equal to 5n. 5 is being multiplied by n, so moving the 5 across and dividing by it is going to give us 120. So again, that is going to mean that term 120 is going to have a value of 603 in this number pattern. And I think I have one more example that we can have a look at, which incorporates almost all of the questions. This one just doesn't ask you to work backwards. I will add a 7th one here now that will ask you to work backwards. Okay, let me get rid of these calculations we did earlier. So, let's firstly just add a 7th question here. Let's say 7th question is going to be, let's see, determine which term has a value of, now I need to do some maths, so I can pick one that will actually work. It will be part of it. Let's see. I'll fill that in a second. Once we've gotten the general term, then I'll fill in which value I want. Okay, but we can make this a bit bigger so long so it actually fits in, not bullet pointed, make it bigger. And we can bold it. Here we go. It's a bit better. Okay, and I'll fill the value in now. Let's first have a look at what is given to us. We are given the number pattern 10, 7, 4, 1. Okay, so firstly, state the rule in words. As I said earlier, we don't want you to just reiterate the general term in the same words that you write, as in something times n plus or minus something. You're just going to tell us which number you start with and what you do to get to the next term. So let's see. I'm going to just say, starting with 10, with or at, and what are we doing to get to the next term? 10 to 7, we are subtracting 3. So that is my rule in words. Number 2, write down the constant difference. Now, this is where it's important. The sign is going to matter. We can't just say the difference is 3. The difference is negative 3. That is my constant difference. Question 3 said write down the next 3 terms. We can just keep subtracting 3. So 1 minus 3 is going to give us a negative 2. Minus another 3 is going to give us negative 5. And minus another 3 is going to give us negative 8. Again, you could have written it out as term 5 has this value, term 6 has this value, term 7 has that value. Okay, but this is also completely acceptable. Number 4 is where we want to get the general term. So we have already established what our constant difference is. It is negative 3. Now I need to have a look. What do I do to negative 3 to get to my first term? What do I add or subtract? Well, to go from negative 3 all the way to 10, I have to add 13. And again, I'm going to take a random value and I'm going to test it. So let's take the third one. Negative 3 times 3 is going to give me negative 9. Plus 13 is going to give me a positive 4, which means it works out. Question 5 and 6 are very much the same. They are just asking for term values, for specific term numbers. So their calculations are exactly the same. You're going to use your general rule and you are going to simply substitute the term values that they are giving you, the term numbers. So the 15th term and the 120th term. And we can go and calculate those quickly. Let's see. That's going to give me negative 32. And that's what we expect to see. This number pattern should get bigger and bigger into the negatives. Term 120 is negative 347. Negative 347. Okay, and then we have question 7. Now, let me see. Negative 1787. Let's do that one. Here we go. Determine which term has a value of negative 1787. So let's see how we would solve that. Again, that is working backwards. So we're going to take that value, negative 1787, and we're going to set it equal to our general solution. Right, 13 is going to go across. It is a positive 13, so when it goes across, we're going to subtract it. So minus 1787 minus another 13 is going to give me minus 1800. And that is still going to be equal to negative 3n. And the negative 3 is still multiplying by n. We want an answer for a positive 1n, so we're going to divide by negative 3. So negative 1800 divided by negative 3 is going to give us 600. Meaning that the 600th term in this sequence or this pattern would have a value of negative 1787. Okay. And that covers everything that you need to know how to do with constant difference number patterns. You simply need to recognize what you are adding or subtracting, see what you need to do to that number to get to the first term that you were given, and then there's some calculations that you need to know how to do. But there were 3 examples that covered all of them, and this can now be applied in exercise 2, which we're going to have a look at, and it can also be applied to picture number patterns. Okay? I haven't spoken about picture number patterns, I will just briefly talk about it, but it will be in the next video. But any of your number patterns, be it your linear, your quadratic, or your constant ratio, can come in picture format, in which they give you figures. And you need to first just go and count them, but we will discuss that later. So we're going to have a look at exercise 2. I've chosen some specifics there. We've got B, C, D, and E. And let's see what we can do.